to call on stage the panelists and please sit down according to your picture on the wall. I would like to first ask Professor Sasaki to come to the stage. We will introduce everybody in a minute. And then also Miss Hayashi. Here, sorry, excuse me. Thank you. Then I have Mr. Massimiliano De Gaspari. You're here. And last but not least, Didier Vuarnoz. Thanks a lot. So we are a very diverse panel here, coming from very different backgrounds. And so I would like to ask you first, before we go into the questions, to very briefly, 1 or 2 minutes, introduce yourself, what you do, and maybe one thing that surprised you to today, or those who have been here yesterday as well. So let's start from the left. Yeah.
Hello everyone, my name is Didier Vuarnoz. So I'm working at HEMPA. HEMPA now you know, thanks to the presentation of Matthias before. And I'm co-affiliated to EPFL and we're working hands in hands. I'm an energy scientist basically, and I shifted away from operational energy to life cycle assessments because actually to produce the energy system, we also need infrastructure, and to create this infrastructure, then there is a lot of energy which is needed. And we investigate this over the long run, over all the life cycle of this material. What I've been surprised here is especially about this location, Swiss Next in Japan, which is actually has been built from scratch by Felix Meusner, which is pretty recent. And this is a fantastic place. Actually, I know Swiss Next in China or Swiss Next in Boston. And here the place is completely fantastic, great location in Osaka, but also in Japan. And this, I'm very pleased to be here with you today. And I think this is really the highlight of my trip in Japan.
Thanks a lot. Maybe that's a good moment to give Felix a round of applause, right? Thanks a lot. I mean, you already introduced yourself, so maybe you
Yes,
can
I
just
did. Yeah.
switch to what surprised you.
Yeah, that surprised me. I didn't know that the size of Switzerland is the same as Osaka. So I was really surprised and impressed that, that we have so many great universities and an industry in such a compact area. So yes, that's it.
This is indeed something very unique in Switzerland, that we are very close to each other and even speaking 4 languages, right?
Yeah, exactly. Yeah.
Okay, so my name is Sasaki. I gave the presentation on the hydrogen energy, and I was also happy that some of the presentation is related to the hydrogen energy. What I learned and surprise is that again is that yeah, especially in Switzerland, it is so common to you build the startups, but it is some Japan is still somehow behind because most of the graduate students want to join the bigger company like Toyota, Honda, Nissan, and also Tokyo Gas and Osaka Gas and so on. But I think, yeah, today there are also some presentation given by the Japanese on the startups, and I think such culture, yeah. So building the startup become increasingly popular
Mm.
in this country, and we can also learn so much from the experience in Switzerland. And I think, yeah, Switzerland is become also a good role model also for Japan, although also Japanese younger generation to start such startups. Yeah, thank you.
That's a very interesting comment. I mean, in Switzerland, we sometimes also think that we are not good enough yet in the startup scene. With Felix, we are working together on that as well. I can assure you that we are trying there harder as well. For example, we are soon launching a new initiative together with Germany and Austria and Switzerland to promote startups in the energy field. So yes, let's keep in contact there. Please, you haven't introduced yourself yet.
Not yet. Hello, Massimiliano De Gaspari from EM Microelectronics in Maran, Neuchâtel, Switzerland. We are the semiconductor company of the Swatch Group. So we make microchips, silicon microchips, primarily for the watchmaking industry. We have our own fab, so our fabrication capabilities in Switzerland, which have some capacity, and we use most of the capacity actually for other applications. So beyond the watchmaking industry, we serve also many other industries like Bluetooth, RFID, energy harvesting in my case. And yes, we do a lot of different applications, so microchips for many different applications. Um, there were two things that surprised me here today. The first one is to see the audience. I was expecting to have like, I don't know, who wants to show up to such an event? 10, 15 people. Wow, this is a great audience. A lot of people, both from Japan and also flying all the way here from Switzerland. So very nice to see you all here. And also congratulations again to the people who organized such an amazing event. The second thing, which was a bit surprising, was that I came here with the idea of, okay, energy days. There will be a lot of people talking about kilowatts, maybe megawatts. And myself, we are a watchmaking. We have a watchmaking DNA, so we talk about microwatts, sometimes milliwatts. Then I come in here and I hear about terawatts. Wow, I don't even know how many orders of magnitudes are between the terawatts and my micro or even nanowatts. So it's a surprise, and it's also a very interesting thing because it gives an idea of the variety of people that we have here in the audience, the variety of applications and different needs.
This has been a very good keyword, the variety, and I think it's also on our panel. We are in very different roles here, but yet, I mean, if you look at what we are doing, both in terms of how we either working directly in the energy industry or are using electricity as one of our important production factors, we all seem to agree that we need to do something. We need to change our energy system. We need to achieve net zero by hopefully 2050 or at least like around there. And it's a huge challenge. So I would like to start with the first question. We heard many interesting ideas and startup coming up, but also large incumbents, large companies doing like claiming to want to be net zero by 2040, 2050. It's not a lot of time, right? Even 2050 is very short. It's if you think about infrastructure like investments, we are talking about 30, 40, 50 years. And so everything that is, for example, invested today into fossil fuel infrastructure, most probably is still going to be there by 2050. So yeah. So my question to you is like, where do you see the biggest obstacle? I mean, it can be either from your job, but also as a general comment, where do you see the biggest obstacle that we actually achieve this 2050 goals, or at least like in somewhere? Who wants to start? There's one micro that you have to. Yeah.
I can start. Somebody was smiling, but I can start. Of course, each one of us has their role in the industry. I can talk about my role and my challenges. So we work a lot. I focus a lot on energy harvesting systems. So energy harvesting from the environment, like for example, solar, so light harvesting or thermal harvesting. Meaning, for example, today now here in this room we have light coming from the artificial lighting or some external light coming from outdoors, and all these lights get somehow lost in the sense that in the end it becomes heat and heats up the environment, but it's not really used for anything else than illumination. Same thing also for thermal energy, like energy that we have in the air, energy that we have in our body because of our body temperature, difference of energies between my body, for example, and the wall or the display. So all these energies or energy differences are not used, and my goal is to use them for some useful purpose. So we have all this range of energy harvesting systems, which are meant to power up small devices. Again, I talk about best case milliwatts, not terawatts. And I see that basically all of us, or in the society, we have plenty of devices which are portable computers, mobile phones, smaller devices. Talking about our business is the watchmaking industry, and even smaller medical devices. And all of these need some energy which comes from somewhere. And we see a lot of players who are now changing from traditional sources of energy to more modern and green sources of energy. And this transition is an obstacle. It's a challenge because there is some resistance. There is always some resistance. And my personal challenge is to bring the transition to greener and more sustainable energy sources also to many small portable devices which are not yet updated to the latest technologies.
I think that's great and very important. I mean, at the end, we also need the terawatts and the terawatt hours. So, because when you look at the data center, I mean, they're talking megawatts to gigawatts or more. Yeah, so I think probably both needs to be done. Um, yeah, who wants to continue?
Yeah, his question was what is could be the biggest challenges
Right.
is. Um, I would like to say that we have still 25 years, but we can have only 25 years. Yeah, both aspects is important, and but of course this challenge is so difficult and so huge, so each person do have to do what they can do. Yeah. For example, in your case,
Absolutely.
of course, you have to consume the, for example, resistivity of your micro device, and the data center use also huge energy and electricity. And of course, from supply side or energy side, we have to, of course, develop the energy efficient technologies like, for example, the fuel cell, but also the hydrogen could also reduce the CO2 emissions. From other university professor, I may also emphasize one thing. Uh, I think by 2050 or in 2050, next generation take also leadership. Not my generation, but also the next generation. So especially the university take also good take a leadership to educate the researchers and also engineers of the next generation. And in Japan, for example, we are facing somehow the problem that only the limited number of the students will also join the PhD course. And so we have not enough leaders who can also take the leadership in 20 or the 30 years later. So I hope that we can also encourage the younger generation who wish to join the PhD courses. And from my experience, it is nice to have the international experience when they are during the PhD studies, for example, or the graduate student studies. So, for example, personally, I learned so much during my 10-month stay in the Zurich, ETH Zurich. So that changed also my life and also my way of thinking. So I hope that we can also motivate the younger generation to join, of course, such the energy research in graduate school, and hopefully join the PhD course, and hopefully they have the international experience. Switzerland is a very nice place, also for Japanese students to learn so many things. Thank you.
No, I think that's. I just have one additional question for you. Uh, Definitely on the international exchange. I mean, we can work, or we will work on anyhow, and we already discussed. And I think we should move that forward also with other university. Right on Monday, it will be at the Kyoto University as well. So I think this is definitely something we should work on. But one thing I think maybe we have in common as well, also in Switzerland, it's always a challenge how to motivate young students or young people to actually join studies in the energy field. It doesn't need to be necessarily electrical engineering, can also be in economics, or but like to make them interested in this topic. And it's not so easy. I mean, when you have like AI being the big thing, so I wanted to ask you if you have like for the exchange, we're doing that, yes. But for and I think it's a great idea to, as you said, to open the mind, but to actually attract people to mint topics, to energy topics. Do you have any ideas, or what do you do?
Yeah. Um, of course, there is a competition between the different scientific disciplines. Currently, the graduate school, undergraduate student want to join the research laboratory on the AI or the information and so on. but maybe decreasing number of the students have interest to the carbon neutrality. But fortunately, in Japan, still the young generation have strong interest to the climate or the energy-related research. That is a good point. And other point is that many so companies, for example, we heard also presentation in the Osaka gas. Yeah, they are really working hard toward the carbon neutrality. So I think the younger generation still think that after the learning or the make the research in the field of energy, they can have easily to find the jobs in the leading company like energy company, but also automotive company like Toyota. And so I think if the society has also still have a strong interest in the carbon neutrality, then increasing number of undergraduate students, we also joined to come to the energy-related research. Yeah, of course there is a tough competition, but I think yeah, carbon neutrality is very still the hot topics in these countries. Yeah.
No, I agree. And I mean, what we also try to do is like to show that there is entrepreneurship. I mean, it has this link as well there.
Yeah.
To also show that this is at well, you can go to the big companies, but there's also innovation happening. I think that's what we also try to do with large companies and with startups to show that this is a innovative field. Yeah, please.
Thank you. Yeah, my point is the biggest challenge I think is the adaptation by society of new technologies. Like we have a new technology, but we are not the only option. Of course, like we need so many new technologies and also existing, I mean, new like CCUS and DSC, know that. Including fuel cell, hydrogen. So there are many technologies, but how the society is going to adapt and then how to accelerate the bell curve of the adaptation. We cannot wait too many years until the new technology comes up. And then, I am in charge of like PR. So I speak with so many people. And usually for the first time, they say like, no, I don't believe you, like it's too good to be true. And then from there to be able to actually see, well, come to see our laboratory and say, okay, yeah, it seems that it's working, right? And then from there to be able to do something about it and convince the people in their company for the investment or whatever, it takes time, right? And then for the consumers as well, I can see the same thing. How to accelerate that, I think, not for only for our technology, but for the other new technology, I think it's going to be a challenge. Yeah.
Which is not so easy because if you look at the technology's adoption rate, you can
Yeah.
take nuclear power, you can take PV,
Yeah.
you can take electromobility.
Right.
Any of these
Right.
technologies, they
Yeah, but if
take
it's so
decades, right?
great, yeah, if it's so great, I think it's going to be very quick. And like, I have a good news. iPhone, I checked it yesterday. It took 3 years. You see, so like when it's really great, and then when you see that it works, it could be in 3 years. So that's what we need to aim for.
Of course, some people claim that the iPhone was actually not a new technology. It was just a combination of existing
Oh
technologies
yes, of
done
course,
in the
yeah.
right way. But
Okay, yeah,
no, I agree. Of course, that was there are sometimes these steps where it goes very
yeah, yeah,
fast.
right,
But quite often, I mean, even internal combustion engines, when you look at it, it takes a long time until they hit a certain point,
yeah, yeah,
and
yeah,
then it
yeah.
goes very quickly.
Yeah,
And
I checked also CD actually. I'm the old generation, so like CDs. It took 5 years. It wasn't that long. So I thought like, okay, I see the light here. Not too bad. We can name that one. Not decades.
yeah, yeah.
Yeah.
So let's hope it works.
Yes,
Yes.
yes, it works. Yes.
Yeah.
So, in my point of view, the problem about green energy is nearly solved in the sense that the amount of solar energy is much than enough, combined with wind power also. This is not really this kind of problem, but the problem of availability of resource on one hand to construct the system which will harvest this green energy. So what we will construct today, we will be maybe not able to construct this tomorrow. And even if we are speaking a lot about circularity, but when we do the process of circularity, each time we have a downgrading of the material and their function. So this is one of the problem about availability. And the other is about the data. Because if you would like, we speak also a lot about smart systems and so, and smart system actually is based on data. And what we can see, for example, the hot topic of today, AI, the big tech company are very reluctant to give the data. And actually, we don't know, for this specific example, how much does it consume. For sure, you can measure at your computer, but about the data center at the end of the chain, you don't know. So I feel the biggest challenge is about availability of both material and data.
Okay, thanks a lot. The diverse challenges that we have seen. Um, I will then say where I see the biggest challenges at the end. But I would like to open the floor now. In between, we have then some questions for the panel again to the audience here. So if you have any either comments or questions to the panelists here, that would now be the time. We have these mics, right? Or okay, okay, but that's okay. That's okay. Yes.
Here's a question.
Oh, okay. Sorry. Sorry.
Okay, I'm Roger Fasoli, Provost of EPFL and expert and European leader in nuclear fusion, in the hot nuclear fusion. I'd like to ask a question to you. You say, you know, it's a problem of having the technology being accepted, but for me, it's a problem for the technology to work before it gets accepted. If technology does not work, it cannot be accepted. So what do you mean when people come to your lab and see that it works? What exactly do you mean? Because, well, I mean, working in your case means providing energy. And this cold fusion has been proven since decades that it does not work.
We can talk later about it, but yes, in our laboratory it is working and the COP is already over 1. So yeah, and then we're going for commercialization in 2 years. So believe us, it's working, yes. But we can talk about it. I mean, it's not here to talk.
Yeah, maybe you have to invite Amboche
Sorry.
Vasoli
We have a
to the
can
lab.
have a long talk here.
Uh, First of all, thanks for all the statements, and just a little remark for regarding the CD you mentioned. It took 5 years. I think it took 3 years that it was way of a market. It was not existing anymore. The CD, it took 5 years to introduce, and I guess it took about 3 years to get rid of the
Oh
market.
yeah. It
So
takes.
be careful, maybe.
Yeah.
Okay. Do you hear me like this as well? Yes. Okay, perfect. Are there any more questions from the audience? Yes, there's one at the back. Can you hand the mic over there?
Can you also briefly introduce yourself?
Yeah, good point. Thanks you. Yeah.
Again, it's me again, troublemaker. Yeah, small wind energy producer based in Switzerland, FlowGen. My name's David Syrad. One of the things that I'd like to ask the panel is I feel that everybody's searching for one solution, one technology that will replace fossil fuels as the source of energy in the future. But it seems to me that the future is multiple sources of energy. I'd like to hear your opinion on that.
Do you want to comment?
But it comes, maybe it's linked to the next question that has been proposed by our moderator. But for example, in Switzerland, more than 55% of households are for heating is powered by fossil fuels. When I hear from the government that they cut subsidies into the program to make the phase out of the fossil fuel, then that will decelerate actually the transition. So I'm very sad about such a kind of cuts. But that's clear that there will be such a kind of combination of different energy sources which must be put at contribution of the supply and in response to the demand, in my opinion.
Yeah, I also agree with you that actually the best mix of the different technologies is also essential to solve this huge, big problem towards the carbon neutrality. For example, in our university, even though I'm the pushing the hydrogen energy research. But we are also organizing the energy related professors. We have almost 250 professors working the topics related to a certain energy research. Yeah. So I think the best mix is actually the one more important point to solve the huge problems. And I want to mention one thing that hydrogen is actually the secondary energy. Yeah. So we can also combine, hydrogen can also combine with photovoltaic, wind, and geothermal, and bio, and so on. And so I'm also helping different, researchers of the different fields, including wind farms, to realize the carbon neutrality. So there are so many solutions, and everybody can also make the best way and to realize on working together toward the carbon neutrality. That is the things.
Yeah, maybe get to you and then just maybe as a comment also from Switzerland, I fully agree with you. I mean, the broader the mix of different the electricity provision, especially in the electricity system, electricity production, the better. And it especially is true, of course, when you have PV and wind combined with hydropower. That's a perfect mix, right? So of course, we are lucky in Europe at the moment that we can exchange electricity across borders very easily, very effectively, and very flexibly. And that helps to make the system stable. So, I mean, for me at least, it's very clear that the broader we have the mix there, the better. And yes, let's hope that we can still exchange electricity also in the future. Because, I mean, in Japan, as was said before, that you don't have this luxury, right? It's a bit, but on the other hand, you're also bigger, right? So there was a question at the back. Oh, there's a mic coming.
Thank you, Jörg Wolitschek. I'm a professor at Lucerne University. I would have a question to you, Massimiliano. I mean, some years ago, we would have said the big increase in electricity demand will come from the electrification of mobility and heat sector. Now we learn that the really big increase will come from data centers and from AI. So where, from your perspective, do you see the best chances or the highest level on to increase efficiency or to decrease the electricity demand coming from that?
Yeah, so you mentioned AI. So AI is a big word which means many different things, and now we see a lot of tendency to go in the direction of edge AI, meaning you don't need a data center to, you don't need to prompt the data center every time you have a question, but there is AI embedded in your device. In our case, we are thinking about, again, the watchmaking industry, for example, or other small portable devices, IT equipment, and so on. So we are thinking about embedding edge AI, so AI really at the edge, really close to the sensors in such a way that we optimize the use of intelligence, and we also optimize the bandwidth in the end, because with AI and with sensors, you have to communicate data from one sensor to some other place, which is computer, which is network, which is a cloud, and so on. So if you optimize everything locally on the portable device, then you minimize the power consumption and you still have the function working. And this is a key point, because I look at the energy question also from the point of view of balance between some energy coming in, which comes from a lot of people here in the room, and energy going out in some application. And if we manage to minimize the power consumption and minimize the energy that we need for the application, then we're also making the life of this gentleman easier, right? In terms of having to provide less energy totally globally.
I think that's a very important point. At the end, it's about efficiency, right? And I mean, if you look at industrial processes, there's so much low-hanging or medium-hanging fruits in terms of like improving efficiency to just reduce the energy demand in these processes. I think this is something that's quite often overlooked. And we heard it about AI, right? That also there, of course, there are still efficiency gains to be made. So I think it will be interesting in the next couple of years to see if indeed electricity demand from AI goes up like this, or does it stabilize? And then on the other hand, of course, like AI will help to identify these kind of inefficiencies and also help improve. So I don't know how it will be, but I think it will be interesting. Yeah. There was a question right here. Yeah.
Yes, if I may, I'm Jose Navarro from the Asian Development Bank Institute, and thank you very much for the really interesting uh, discussion. And one thing that keeps coming to my mind, when I hear about ammonia and hydrogen, so that it reminds me of Betamax versus VHS. It's all these different, and it's good to have different options. So maybe we are in a future of many energy solutions, but in terms of so going from milliwatts to terawatts and even bigger dimensions from a societal perspective, it's we are interested in having the least necessary infrastructure to produce the most efficient amount of energy in total for the planet. And you mentioned having, if we have solar power somewhere in the Sahara, with 2% of the Earth's surface, we can provide enough energy. No, so not only electricity, but and so from a societal perspective, is it optimal to have so many competing and diverting in investing so much in research in things that may be very inefficient, and having, for example, also with artificial intelligence, which is an energy consumption sinkhole, and not really suited for the things that yeah, it doesn't solve a problem for humanity. That's my point. And would like to have your input.
Maybe I start first. First I have to say, yes, of course, research is very important. That's because
Nobody
I work for
doubts
ETH
that.
Zurich, right? No, no, no. Yeah, I think that that's part of humanity, right? That we have to try new things and try to find new solutions. I think this is clear. What we will have until 2050, I think this is unclear. We have the ITER project that goes for decades, and yes, maybe at one point we will have something there, but most probably not by 2050. But we still have to go on because after 2050, still the world hopefully still exists, right? So, but sorry, that was just I had to make this comment. But I want to give the word to the panel.
I just want to give a quick comment. So my answer is yes, and the reason being that we are referring now in this discussion to past video systems. So it's somehow easy now to say, oh yes, we tried so many video systems, and in the end this one won and the other one's lost, because now we are in 2025. But now we don't know which one will win or which ones will win in the next 25 years. So we need to try many different ways. Now the question if there are too many or not, this one I cannot answer. But it's good to have many different ways.
Uh, yeah, I repeated a similar comment. In the field of energy, I think there is no one solution which can solve everything. So we have to, in parallel, so make also research on the different technologies. Maybe one technology dominates a certain part, but other technology may also cover the other field. And so I hope that, yeah, even though we have to invest to too many different technologies, but I think it is still important to make the support each different technologies. Yeah.
Do you still want to add? Yeah.
Yeah, I think we can have also new technologies need like a different stage of development, and that's one reason why we have to keep going the research for that kind of technology. But the other thing is that once it's also usable, and depending on the setting, for example, like a sunny countries can use more solar, and the windy countries can more wind technology. So that kind of thing, and the hot fusion is a bigger thing, and then cold fusion is a smaller thing. And so like we can use different energies solutions for different use and in different regions. I think that's why we need many options. Thank you.
So thanks a lot. We are slowly getting to the end. So I would like to ask one last question to the audience. And the reason is a bit, in the audience here, to the panelists, and the audience here, we have industry, we have research, we have startups. It's a great mix, but at the end, there's also regulation, right? And we have regulators, we have governments. They are not here right now. So maybe that's also a good thing. And that's why I would like to ask you this question, because then we can take it with us. If you would have a wish open to regulators, to parliament, what they should change in the next 1-2 years, 1 to 3 years maybe, what would it be?
Policymakers are human. They have all different kind of sensibilities, and I respect that. But what I would like to say to them is, please make decision-based decision, because what we see, for example, these days with some leaders over the world make nearly no sense. That will be
Which
my
would be,
final remark.
please make sense. Okay. Yes. Okay.
Right. So as I said, the biggest challenge for me is like the adaptation by society. So I wish policymakers to help accelerate it. So like for example, like a subsidy, like a wind power, solar power was promoted. That was good. And also regulations so that they don't discourage the adaptation. So those anything that they do should accelerate. Like when the things are there, then why like push them forward. Yeah.
Anything concrete?
Anything concrete? Yeah. Well, the subsidy I think is good, and then carbon credit also it helps.
Okay.
And also the regulations that will be helpful. And then I hope that as long as it works and as long as it's safe, then it should be like a too much regulation. And just for the sake of regulation, I think that's what they should avoid.
Okay.
Hopefully, yes.
Professor?
Yeah. In my presentation, I mentioned that we have many visitors. So more than 70,000 visitors in this to our universities. But I didn't mention, including congressmen, ministers, and vice ministers, and so on. What I learned personally is that university professors have also a job until the retirement, so 65 years old. But of course, the politician, if they lost in election, they lost their job. Yeah. And fortunately or unfortunately, a congressman and politicians have to consider the short term. Yeah. But on the other hand, the effort toward carbon neutrality is really the long-term effort. Yeah. So even though politicians want to emphasize so popular manifest to the election for the ordinary people, but on the other hand, it is so important to have the certain mechanisms to ensuring the long-term investment, especially in the green innovation. Yeah, and that is also one of the reasons why we are always talking to the politicians that we need also law for the hydrogen. Yeah, 10 years ago, they don't care about that. But after we have now the Hydrogen Society Promotion Law, now the government can also, and also almost all parties has agreed. And now also all politicians is always happy and to continue on such a long-term investment. And that's the reason why we have, for example, the Green Innovation Fund supporting the energy-related research for 10 years. We have also GX research, DS funding of the 20 trillion Japanese yen for the energy transition. And such support program is ensured by such then policy and law systems. So even though the politicians have to work and hard and emphasizing such a popular short-term manifest, but we have to have the good system within the policy level, ensuring such long-term investment for the future. Yeah. Thank you.
Thank you.
So I agree that regulations can accelerate innovation and transitions, and I think this shows also what we expect from regulators, from the politicians, say like that. I think there are several reasons why organizations, people, companies decide to make a transition towards green energy, towards energy investing, towards any transition they want to make. So the transition can be because, for example, they truly believe in it, which is great. The transition can be because of financial reasons. They say that if they transition to something different, in the end they will have a return on investment. It could also be because they see a value, meaning like I talk about my specific cases, they see that with the transition, they can offer value to their customers that they would not be able to offer if they do not make the transition. So I see, yes, we can ask, say, in generally speaking, the politicians to make regulations which facilitate the transitions, but in the end, I see it as my, say, everyday duty to also create business cases and create value and innovation that really brings a benefit to an organization, to a customer, in such a way that the transition happens naturally without being forced by regulations, for example.
Okay, thank you very much. So we are at the end of this time for the panel. I would like to give a round of applause for the panel again. Thanks for joining us here. And of course, anybody has questions later on, we will be around in the apple. So please take your seats again.